If you think about studying, really think about studying. When were you taught to study? Were you taught in elementary school? Were you taught in high school? Were you taught in college? Or has your study habits just been a fact of you sort of just do it? You sort of thought, hey, I took this class, I did these assignments, I have this exam coming up, I need to review, I've been told to study, so I'm going to review the content that I've been given. Or I'm going to take a practice exam, or I'm going to try and find different things, but have you ever truly been taught how to study? I'm Albert Lionel, and in this video, we're going to explore research-based study practices that have been proven time and time again in different fields for optimal study habits to help us improve retention. Because so often we're studying in ways that don't help us. And this video in particular talks about a habit you need to get into if you really want to be successful at studying. So when we study, we can think about different things we have done. And in literature and in research, restudy is the most common way a lot of us study. We review notes, we go over past assignments, we look at videos, we look at lecture slides, and we go through and review all this. That's called restudying. And we're sort of going to break these up into groups so I can better explain it. Retesting is when we take a practice exam, when we maybe use flashcards where the answer isn't right in front of us, and we're trying to quiz our brain to bring it on out. We have massed or blocked practice, which is studying all at once, often called cramming. When you have an exam, every single person out there is probably crammed for an exam at some point in their life. They sat there, they panicked, they spent the whole night studying, and then they sat down at the exam and they forgot everything they studied. We also have spacing, and spacing is taking studying in small chunks separated by sleep intervals. And this is critical. The idea that instead of studying for an hour one night, you study 20 minutes across 3 nights, same amount of time dedicated in your schedule, but you chose to break that up across 3 nights with a sleep interval in between. And that is known as spacing. So of these practices, which is best and why? What do we need to do to really retain that information? And one of the things I like to do is I like to bring up this matrix. We have this restudy and mass, retesting and spaced. And I will sit there, and I've done this for years, and I've asked students to raise their hands, and I say, all right, how many of you restudy? And the vast majority of them raise their hands. We all have. How many of you have crammed for an exam and really looked at cramming? Majority raises their hands. In fact, most people in the world fall under restudied and massed. Some people will raise their hand a little bit about testing themselves, especially when I talk about flashcards, and even less raise their hand about spaced practice, about the idea of studying 20 minutes 3 nights a week versus 1 hour 1 night a week. However, this is actually the ideal habit you want to get into, and the reason is our brain is sort of tricky. When we do massed practice, we have a lot of information that we're taking in, and our brain is trying to reinforce it and say this is important. But what happens is for most mass practice or cramming, it is good for short-term memory, not long-term recall. And when you're talking about the sciences, especially computer scientists, we want long-term recall. Everything builds on each other. So the more we can focus on long-term recall, the better, the more successful we'll be. So mass practice is a really poor way to study, especially for computer science, because it focuses on the short-term recall. Where spaced practice, going back to the 1800s, and it's been repeated even to just a few years ago, specifically within computer science, the idea of breaking up your study intervals with sleep cycles in between, spending 20 minutes a day, 3 days a week, or 3 nights, or whatever works out in your schedule compared to that hour studying for the exam, you will do better. So between mass and space, the more you can practice spaced practice, this has been documented again and again to be the best way to retain information for long-term recall. What about restudying and retesting? Restudy is incredibly tricky. I mean, right? Going over notes makes sense. I haven't talked in a video the importance of creating notes. But going over your notes again, our brain tricks us. It does. In fact, I would argue it even lies outright to us. Because what happens with restudying is we look at our notes, we look at the slides, we look at the video, and our brain likes familiar items. You see a friend walking down the street. Hey, our brain triggers. Endorphin rush, that's somebody I know. You see somebody you don't like walking down the street, you still get an endorphin rush because your brain recognizes it. It is reinforcing, saying, I recognize this, I see this. So you get excited and your body reacts to it, and this is a great thing. You see it, and then you stop studying before your brain has actually triggered and made that association that this should be long-term memory. We think we know it, and study after study has shown that doing re-study as your primary study habits, you stop before you actually retain the information. And sometimes you can push yourself on through, but our brain is lying to us. We're fighting against ourselves the entire time because we're getting this release of endorphins. We're being excited that we've seen it, so we think we know it. But when it comes to recalling information, we actually don't. Where retesting forces the brain to say, wait, this is important. The answer's not in front of me. Do I have this information? If I don't have this information, I need to solidify that memory pathway to make sure I have it. And so retesting forces your brain to work, sort of like working a muscle. It's not just, hey, I'm looking at somebody weightlifting. Instead of saying, I am doing the weightlifting. I am sitting here. I am focusing in this. I am building this muscle by reacting and saying, I don't have this memory, so I need to solidify it as there. And that is why retesting, not having the answer in front of you, then trying to come up with the answer, is so critical. The problem is we aren't often given the tools for retesting. And even if we are given the tools, we aren't necessarily told how to do it. So for the remainder of this video series, we're going to talk about how do we do this? How can we make this our habit? So first, build the habit. Time management. That's one of the hardest things we have to deal with. So add it to your calendar. Say, I'm going to study for this class 20 minutes a night, 3 nights a week. This class, another 20 minutes, 3 nights a week. This is above and beyond your homework. This is time just dedicated to studying. And that's the hard part, is we're very task driven. And the idea of adding time just to study when we have all these tasks to do is hard. So building that habit is essential. There are graphs that will show people study habits. And what happens is they think they're doing spaced practice, but in practice, they're actually doing massed practice. They wait until exam, they wait until that task is there, and then they study. But it doesn't help if you don't break it up by multiple sleep cycles. So if you really want to study, really break it up. Even if it's 3 or 4 days from the exam's coming up in a week, start studying every night. Ideally, you've been studying every night throughout the entire semester to the exam, then you don't have as much to do. And it only has to be 20 minutes. And it's interesting for these habits. I had a group of students who really took this to heart. And in my class, they got A's, and then in the following class, they got A's. In the next class, they started to get A's. We noticed this group of students was all doing really well in every class in computer science. I was sitting there talking to one of the students, and I said, hey, the faculty are saying you guys are doing really well, which is awesome. What are you doing? And the student says, oh, we took into account and we really took to heart the study technique of doing a little bit every day. And we did is, as a group, we all built questions together. We all put them actually in a Google Forms quiz. And we all add questions every week. We each add one question to add as a group of us. And then we all make sure we study daily. In fact, we hold ourselves accountable to it. Now, this student, in his case, said, I brush my teeth. While I'm brushing my teeth, I pull up the quiz and I start quizzing myself. And then force myself to brush my teeth longer and do the quiz. And then maybe when I'm doing my morning tea, I do some more questions. And so he didn't necessarily do it in 20-minute intervals. He did 5 minutes here and there throughout his day. And he was a full-time student while working full-time. So he was trying to balance this busy life schedule. Trying to find time to study was really hard. But he made it a habit of these 5, 6, 7-minute intervals throughout the day of studying. And his grades and his performance showed for it. And everyone in this group showed for it. So sometimes when you're building a habit, one of the best things you're going to have is accountability partners. People that help build this habit with you, and then you work on studying together. For building questions. What if we need to build our own questions? What if questions aren't given to us? Well, this is a habit that is critical. This habit says, after every lecture, write a few questions down. This creates engagement. In fact, it's known as a creation level of engagement. If you notice, it's really far down that tree that we talked about in a previous video. The idea behind it is the fact that you have to sit down after your class. Yes, you go through your notes. Yes, you go through the slides. And you ask yourself, you sort of, it's called elaboration is what we call this in the field. You ask yourself, how do I think like the instructor? How do I go beyond what they showed me in class and create my own question? I'm creating an exam, maybe one question at a time, but I am creating an exam one question at a time, one from every lecture or video, and I am going to do it. This also helps consolidate your thoughts. This is a powerful technique. And then after you've created this question, you can build from there. You can study it. You can shuffle it. Every night you go through a few of those questions. You shuffle them again. You go through a few because you sort of want to intermix them so you're not going in order. You want your brain to have to sort of recall all together. But building these questions, shuffling, and just doing this little bit every night is huge. We did this as a research study of computer science students. The students who started off failing a course, they hit their first exam, they all failed. Those who practiced this habit, after every lecture, they built a few questions. 3 nights a week for 20 minutes, they would study, they would shuffle their questions, and they'd pull out different ones, and whatever they got done in 20 minutes, great. If they didn't get any more done, great. They didn't keep at it. They said, I'm spending only 20 minutes. But they would shuffle, and they would do this every night. Well, 3 nights a week, every week. And every single one of them turned their grade from an F to passing. Now, passing is a C or above. Vast majority of them are B's and A's. Technically, there's just a couple C's in there, but the vast majority were B's and A's, and they went from failing on the first exam, and that exam even factored into their grade, so they had to outperform all their other exams, all their other assignments to bring up their grade, and they did it tremendously. But they had to first build this habit. So it works. It works in computer science. It was done for a data structures course, a critical course of a computer science program. And all it took, and I say all, because this is a pretty big habit to build, was writing exam questions, shuffling the cards, and going through them 3 nights a week. We talk about questions. What are good questions? Definitions of define this, or what does this? And you come up with a definition, bad questions. Really, I mean, we sort of get the idea from it because of learning languages. But if you think of a question as a flashcard quick answer, you're not really triggering your brain. You're not really forcing your brain to dive for that information. Instead, especially for computer science and STEM-based disciplines, you really want to focus on problem solving. And some of it may be definition, but you want to expand it out. So here's some examples of questions, or at least one's an example of question and the other examples of what you can do. And it helps you to consider what is a good question versus a bad question. And honestly, this is the hardest hurdle when we did that research study students had to get over. They were so used to doing definition-based questions that they had to really focus on how do they build a good question. So here's a question. Given a singly linked list structure, if you haven't studied singly linked lists yet, that's fine, doesn't matter. It's data structure and computer science. With a head-only node, talks about time complexity. That's more of a definition thing, but you can figure it out. You don't have to actually know the definition, so you can figure out. And then write pseudocode, or write real code if you're in front of a computer, but I'm assuming you're just sitting there and you're like, okay, I need to figure out the pseudocode of how this works. Now you add a tail node, even though it's still singly linked, how does that change things? Write pseudocode. And then what if you needed to use a list? What are some ideas in using it? And what I often suggest is when you have something like this, have like 10 ideas that you've brainstormed, researched, found, and try to come up with 3 of them on the spot, or don't try to memorize all 10, just try to logic your way through it. And then write code to reverse a singly linked list. It's a challenging problem, but this is all tied to one question card. It may take you 5 minutes to do it. You may only get to 4 questions a night. That's perfectly fine because you're triggering your brain for these problem-solving ideas. Another idea, what does this following code block do? And you give yourself a code block that's related to the class session that you had. Then pick key things to change. What happens if you change this sign? What happens if you change this conditional? Or you make it less than to a greater than? What happens if you want to do X or Y? So not only define what the code blocks does, really push yourself. What happens when you change different variables in it? And then that is part of your question. What happens when you change this? Does your output change? What happens if your parameter changes? So you really start elaborating on just not what this code block does, but really expanding on different possibilities. So it's no longer one code block, it's a code block with possibilities. And then always a good one, or back to a definition, what's the runtime complexity of this code? Something you have to figure out, but now you have to know in the back of your head what is the definition of runtime complexity without saying, well, what's the definition of runtime complexity? So you've worked a definition into the problem without it being a direct definition. And yes, it's all right to do multiple choice and true and false. Your exams are going to have them. So it's all right to do them, but don't default to them. Don't make them your only questions. If you make them your only questions, your brain really doesn't trigger. It just sort of tries to memorize them all. And then you can say, oh, I've seen this before, I got it memorized. This is what it is. So when you're thinking about questions, when you're creating these questions to work with, really think about how it can trigger your brain and push your brain to elaborate more, to expand upon it. And if you do that, you'll have better questions. And then when you restudy, your brain is really going to start firing and saying, okay, I need to learn this. And when you are stuck on a question and you have to figure out what the answer is because you want to create the answer with it, then you're like, oh, okay, I really need to know this and I need to figure out how to work on this. And so when it comes up again, you'll have a better idea and have a sense, oh, this is how I did this. And so when you have a similar question on the exam, now you can say, oh, I sort of recall how I did this. Let me go through this process that I've sort of learned, and then I can go through that. Also, don't forget to make use of the tools provided. Some instructors will do weekly quizzes, and they're usually low stakes quizzes, or they're quizzes that can be redone as many times as you want, and that's actually ideal. I call them knowledge checks, other people call them learning activities, some people just call them quizzes, but the idea is your instructor is trying to give you half this problem. They're saying, I am going to give you the tool to restudy. Your job is to practice spacing. So if your class is a knowledge check-in, if you happen to be taking one of my classes or a class I've worked with an instructor for, anyone else who tends to do that, and they say, here's some questions pulled from a question bank, every time you take this quiz, it's going to be different, you should do that. They're giving you half the problem. They're saying, I'm going to help with this, but you need to bring the spacing to the table. You need to say, I'm going to spend 20 minutes taking a quiz. When I run out of time, I run out of time. Awesome, we're going to just take one quiz every night, 3 nights a week. It's going to be randomly selected for my past quizzes, and you will do better. One of the worst habits we've seen is people try to do all these quizzes for cramming, and they never get a chance to practice it, and we can actually document that you do worse doing that. So don't try and do that. Really try to focus on, I'm going to do a little bit, 3 nights a week, all the way up until the midterm or the final exam. And then when you get to midterm or final exam, it ends up being a pretty easy week because you've already been studying. You don't have to cram nearly as much. I should say pretty easy week. There's other things that often happen, but you get the idea. Some instructors do practice exams. Great. Those are questions that can go into your question cards. Some will give study guides. Great. Those are things that actually help you build these questions. In-class examples, convert those to a question. Book examples, even better, convert those to a question. In math books, this idea of retesting has been around long enough that we've all probably had a math book where every even problem, every odd problem, the answer's in the back of the book. The goal for that wasn't so you can go ahead and say, oh, I'm just going to look at the answers when they give me on my homework, or I'm just going to spend one night and try to do them all. The goal was really to do the spacing plus retesting. Pick a random question, work on it one night, see if you got the right answer. Pick another random question, work on it a different night, see if you get the right answer. So the fact these tools exist, but they don't tell us why they exist, can be sort of frustrating as a student, but it is also wonderful for you when you do know and you can use them. If you just pick one of those questions a night and you practice it, you'll be surprised on how much you can learn, even on the math, which can be struggling for people, myself included, when I first dove into it, until you started building this idea that this is problem solving one step at a time. So I just have to figure out how to problem solve. In computer science, I wanted to mention a very specific area. We call them challenge coding problems or challenge problems. Sometimes your instructor provides them. Sometimes you just go to codes like websites like LeetCode or CodeSignal. Sites that provide these challenge problems, and you actually provide them for technical interviews, but you as a coder can use these to study because it gives you a problem, it has a way you can test the problem, and you write the code to do it. And maybe every time you hit the problem, if you hit the same one again, you try to write it a different way, you write it in a different language. The key is to really practice, and this practice and this habit of practice is how you truly become a better computer scientist. So the tools are out there. You just have to build that habit. So in summary, build strong habits. You want spacing. You want to go ahead and do 3 nights a week versus 20 minutes each versus 1 day at 1 hour. You want to do it every week going up to the midterm, and that is the hardest habit. The second habit is retesting. Don't just go over your notes. Yes, when you created your notes, it's a valuable association tool, but they should not be the definitive for studying. They should help you be the starting point for studying, but you really need to retest yourself. You really need to quiz yourself without the answer there, so your brain has to struggle through getting the answer. And once your brain is struggling through getting the answer multiple nights in a row with a sleep cycle in between, you will have retention. This has been documented, it's been researched, it's been proven time and time again to be successful for long-term recall, no matter the field. So build that habit, practice, and you can be successful. Thank you.